Hello, I'm here to help you with some problems on your homework that we've received some questions on. So this is for homework 5. This is going to be questions 34 and I believe 36. So let's go ahead and go back to question 34 first. We're going to go backwards a couple. So that's 35 and let's go back to 34. All right, I'm just going to restart work. That way this gets us a nice clean answer. So let us go through and read this question. All right, so starting on the left, a sample containing 5.2 grams of oxygen, O2 gas, has had initial volume of 21 liters. What is the final volume in liters when gas of the following changes occurs in the quantity of the gas at constant pressure and temperature? You may want to reference page section 8.6 while completing this problem. So this is going to have to deal with Avogadro's law. Avogadro's law relates to volume and moles. So if I'm going to write that out, I'm just going to scroll down here on the left side. I'm going to say that when we think about Avogadro's number, or Avogadro's law, not number, the volume, the initial volume and the initial moles ratio will be equal to the final volume and the new moles amount. So don't forget, we have to deal with moles. So if you're given mass, you have to convert to moles. So first up, let's just work through all of them. I believe I only had a question on B and C, but let's go through all of them just to make sure we're all good. A sample of 8 mole of O2 is added to the 5.2 grams of oxygen in the container. So let us set this up first. Our V1 is going to be 21 liters. That is going to be our V1. And our N1 is going to be 5.2 grams of oxygen. Now, like I said, we have 5.2 grams of oxygen, but we need to convert that to moles. So 1 mole of O2, if you go to a handy dandy periodic table, an oxygen atom weighs 16 grams. Therefore, since I have 2 oxygens, it's O2, this should be 32 grams of O2. So now I'm just going to grab my handy dandy calculator. And I'm going to try this now. So I'm going to divide 5.2 divided by 32. I'll do the math here. And I get 0.1625 mole of O2. So now I'm just going to put that down here, 0.1625. All right. So now this is going to be equal. I don't know what my unknown, my new volume is, right? Because I am adding 0.8 moles. So I'm going to add that 0.8 to my 0.1625. So now this is going to be divided by 0.9625. Okay. So now this just becomes an algebra problem. I'm going to multiply both sides by this term. And so now what I should get is going to be 21 times 0.9625 divided by 0.1625. So when I do that calculation, so times 21 divided by 0.1625, right? And I get an answer of 124.3846. And I'm just writing out a lot of digits. It wants us to go to 3 sig figs. So 1, 2, 3, we should round here. So our answer should be 124. Just as a quick check, I have 0.1625 moles when this question starts, and it's at a volume of 21 liters. I am adding moles, therefore my volume should increase. This makes sense, all right? So I'm going to add 124. It should be in liters. We'll hit submit. Hopefully this went through. Yes, that is correct. All right, so let's go ahead and try the next one. I'm just going to clear all of this off, and we'll roll down to part B. Again, we're still using the same idea. All right. A sample of 1.5 grams is removed from the 0.52 grams of O2 in the container. So I started with, turn on my annotation, 5.2, but I'm now going to subtract 1.5. So now I'm left with 3.70 grams. And again, I need to convert this to mole. So this is going to be 3.70, and it'll be the same calculation we did up above. So it's going to be 1 mole of O2 has a mass of 32 grams. So basically now when I do this calculation, 3.7, 32, and I get 0.115625. So one thing I always like to tell students is when you're doing these problems, don't round till you get to the end. because you don't want to like shortchange your answer. And so if you round enough in a problem, you can affect your answer. So now what we're going to do is that we are going to say, all right, our original volume here is on the left was 21 liters, right? And then we had 0.1625 mole originally, because remember we did that conversion up above. That's going to equal our unknown new volume X, we'll call X liters. And that's going to be divided by what we just calculated, 0.115625. And we're going to do the same thing. We're going to multiply both sides by this, by the denominator, 0.115625, and then get our answer. And so when I do that, that times 21 divided by 0.1625. And I get 14, when I solve for X, 14.9423. And like I said, this is just me writing a lot of values down. So then I round to the third one. So this should be 14.9. That is the 9, 14.9 liters. So let's double check. Make sure I didn't make a mistake in my math. And yes, that's how we do it. So just make sure that you're paying attention to whether you are dealing in mass or moles. So whenever you do any of these calculations, if it's going to be moles, so you have to convert your grams to moles. All right, so let's go ahead and clear this off, and let us go to our last part C. A sample of 2 grams of oxygen is added to the 5.2 grams of O2. So it's basically the same idea now. So we're going to say 5.2 plus 2. So now we should get 7.2 grams. And then we're going to do the same thing. We're going to multiply it 1 mole of O2 has a mass of 32 grams, right? The oxygen weighs 16. So now I'm going to do my same calculation again. 7.2 divided by 32. And I get 0.225 mole. All right. So then again, I just set up my same thing, my Avogadro's ratio, my Avogadro's rule. So I started with 21 liter. That's divided by 0.1625 mole. Remember, we got that, calculated that in our first problem. That's equal to my unknown volume, X liter, right? And that'll be divided by my new amount of liters, moles is 0.225 mole, all right? So again, I just multiply the left side by this 0.225. So that times 21 divided by 0.1625, and I get 29.0769. Again, the 3 sig figs, so that 0, it's going to round up to a 1. So this should be 29.1 liters, 29.1. So let's go ahead and put that in. Hopefully that is correct. And yes, so that's how you do it. So the big thing here, make sure you are properly converting from grams to moles. That is the big thing. I'm going to go ahead and clear this off. And then we had another question about question 36. So let's go ahead and go to 36, making my way downtown. Okay, so I'm going to go ahead, since I did solve this a little earlier, just because I wanted to make sure that I could explain it to you in a relatively simple fashion. All right, so it says here, use the molar volume to calculate the following at STP. So if you remember, this is something that you would have seen in 8.6. At STP, which is standard and helps if I turn on the writing tool, at STP, right, 1 mole of gas has a volume, that's the equivalent sign where it's like, looks like an equal sign with one more, has a volume of 22.4 liters. So we can go ahead and do the exact same thing that we did, Avogadro's law. So we can go ahead and say 22.4 liter, 1 mole, will be equal to, calculate the number of moles of CO2 in a 3 liter of CO2. So we're going to go 3.0 liter here, and we are solving for mole. So we're going to multiply both sides by our X mole. So that's going to move that over here. And then we're going to divide both sides by our 22.4 liter. So then what we're going to get, I'm going to put on the right over here, is going to be our unknown mole, right, divided by 1, that one's still there, is going to equal 3 liters divided by 22.4 liters. So I simply will go to my calculator and type in 3 divided by 22.4, and I get my X mole is equal to 0.115625. 0.1339228. And again, I am just adding extra digits, that's a 9, so that we can clearly round. We round to 3 sig figs, so that 3 is going to become a 4. So that should be 0.134 mole. So I'm just going to simply type in MOL for mole. So we'll see if that's correct. All right, so that's just the relationship. The trick here is to remember when we're thinking about this, that STP, 1 mole of gas, has a volume of 22.4 liter. That is how you solve this. But let's go ahead and continue on, because I believe it was part C that was giving our student problems. So let's go to part B first. And it says, calculate the volume in liters occupied by 0.12 mole of helium gas. Again, we're going to use that same relationship. So 22.4, right, liters. Per 1 mole. It's going to equal, we don't know what volume you have, right? Because it's calculate the volume. So we're going to say X liters by 0.12. So we're simply going to multiply the left side by the 0.12. So 22.4 divided by 1 should be 1. Any number divided by 1 is itself. And then we're going to multiply that by 0.12. And now I get 2.688 liters. I'm rounding to 3 sig figs. So this should become 2.69. I'm going to go ahead and, didn't mean to do that, but 2.69 liters, 2.6969 liters should be the correct one. And so we'll hit submit. Hopefully this works. Yes, it did work. All right, so let's go to part C. So it says calculate the volume in liters occupied by 8 grams of O2 gas. So if you remember what we just talked about in question 34, we have to make sure that we convert from grams to mole. If we don't do that, we can't do this problem because Avogadro's law deals with mole. So we're going to do that first. So first we're going to say I have 8 grams of O2. We're going to multiply by its molar mass. So 1 mole of O2, as we saw in the other problem, has a mass of 32.0 grams. And that's because each oxygen atom weighs 16 grams. If you look at a periodic table, so 2 of them, 16 plus 16 is 32. I do this calculation now, and I should get, without doing my calculator, should be 0.25, but let's just use our calculator just to be sure. And it's going to be 0.250 mole of O2. So then I'm just going to use that exact same relationship. So 22.4 divided by 1, right? We don't know our volume because that's what we're solving for, divided by 0.250. So I'm going to take that, multiply my left side by 0.250. So times 22.4, and I get 5.6. So now it says answer to 3 significant figures. So this is an important thing here. It's 5.6. So since we need 3 significant figures, 5.60. You've got to add the extra 0 because it needs it to 3 sig figs. And then we are simply going to write liters here because we are calculating volume, right? We're thinking of volume, it's always liters. Hit submit, and yes, it worked. Life is grand. All right, hopefully that makes sense for you. And now let us go ahead and clear this. There's a part D, you might have gotten this, but let's just go ahead and make sure that you understand it. So it says calculate the number of grams of neon contained in a 16.7 liter sample of neon gas. So of course, our same ratio, our same relationship, right, that we've been saying, 22.4 liter, right, per 1 mole is equal to, in this case, 16.7 liter for X mole, right? We don't know how many moles we have of this. So I'm going to multiply both sides by X mole to move it over here. And then I'm going to divide the right side by 22.4 liter. And I should get X mole equals 16.7 liters divided by 22.4 liter, right? My divided by 1 just cancels out. Because remember, any number divided by 1 is just itself. So I'm going to do this calculation. So I get 16.7 divided by 22.4. And I get that this equals, our X mole equals, I'm doing it here on the right, 0.745535. And like I said, I'm trying this out. But here's the trick here, and this is something that may have gotten you guys. It is asking for grams, right? This is grams it wants. So this is mole. So I'm simply going to take this and I'm going to multiply it by its molar mass. So if I go to a handy dandy periodic table and I look at neon, I see neon has a mass of 20.18 grams for every 1 mole So if I multiply this by this, I'm going to get, so let's go ahead and do that, times 20.18 divided by 1, and I get 15.0449. So I'm going to round to 3 sig figs. So that should go to 15.0 grams, 15.0 grams. Hopefully this is right. So we're going to type this in, 15.0 grams. It wants mass. That's where you have to pay attention here. So you solve for mole, right? Because Avogadro uses volume and mole. And look at that, we got it right. So hopefully that helped you solve these problems. I really hope that it worked. And I hope you guys have a wonderful rest of your day.